Hello everyone. Today I would like to talk about zinc storage in Drosophila fruit flies and how this could impact our understanding on zinc deficiency around the world. Zinc deficiency is a major global health concern, especially in developing countries. In Mexico, it's estimated that roughly 20% of the population is suffering from zinc deficiency. Zinc itself is relevant for health of pregnancy, the immune system, and child growth. As such, As such, children and unborn kids are among the worst victims of zinc deficiency, with roughly 500,000 childhood deaths per year due to malaria, diarrhea, and pneumonia. So, how can we avoid zinc deficiency? As it turns out, fish, seafood, and meat are among the best sources of zinc, while fruits and vegetables are among the worst. When our son was born underweight in early 2020, our pediatrician was worried about severe COVID-19, so we had to include meat or fish in every possible meal. In my opinion, this is not a viable or scalable solution due to the environmental cost and also the economic burden. So what could be an alternative? So the question becomes, why is a meat burger just better at delivering zinc than a vegetarian burger? So what is the secret ingredient of the meat burger? We study in our labs in Mexico City how metals like zinc, iron, and copper are being stored in animal models like Drosophila fruit flies. Why? Well, they are just so similar to us, with 60% of shared DNA, and which can be easily mutated. And in a previous study, we found that the Drosophila with these bright red eyes was showing dramatically reduced levels of zinc. These mutants became our model for zinc deficiency. The mutation itself, which is the cause of the red eyes, interrupts the kynurenine pathway, which transforms tryptophan into kynurenine and other compounds along the way. And tryptophan is an amino acid, therefore a fundamental building block in nature and present in a lot of foods like meat and seafood. The kynurenine pathway, on the other hand, is relevant for the immune system, so already quite a nice bingo, right? And so could tryptophan be the secret ingredient, and how would we measure that? Well, first we took our flies and grew them on different diets, then we dissolved them in acid, and then we burned them to a plasma, which is just a good reminder that science can be pretty metal. Thank you. So shown here is how the zinc in the fly depends on the zinc in the diet. And as you can see, flies grown on a low tryptophan diet stayed below the normal levels of zinc shown in blue. However, growing the flies on a high tryptophan diet, immediately the flies were able to surpass the normal levels even at low amounts of zinc in the diet. So in conclusion for us, that meant that tryptophan regulates zinc uptake in Drosophila, which is a major, major shift in our understanding on how zinc uptake works. And what about the remaining parts of the kynurenine pathway? So this is where my part comes in. As a physicist, I specialize in performing X-ray experiments in these football stadium-sized facilities around the world, for example, here in Berlin or there close to Zurich. Without the pandemic, I would take students and train them on site. During the pandemic and this project, I would just stay at home, connect remotely, and try to train my son with very little success. And so today, I would like to be Oprah, and I would like all of you to be the X-ray scientists. So just as in the start with Go Gain, 3 to 1, 5 yes or no questions, and you're an X-ray scientist. So I perform the experiments on the organs that store zinc in the fly. As you can see here, we have the absorption of the zinc in these organs of the incoming X-rays of different energies. These lines represent a unique fingerprint of the zinc in the organ. And so if two lines overlap, you can already conclude that the zinc in both organs is equal. That's the source of the 5 questions. So the first lines we see now is the zinc in the control fly and the zinc in the zinc deficient fly. So are they equal? 3, 2, 1. Great. So, but how about we take the zinc deficient flies and put them on a kynurenine diet. Are they equal now? Great. So the zinc deficiency could be healed by adding kynurenine to the diet. Oh, sorry. Still unsatisfied, we were wondering if zinc, the connection between zinc and kynurenine was not just figuratively, but literally, like the difference between you crossing a street because a policeman is halting traffic or because your mother is taking you by the hand. So we investigated how zinc binds to the molecules of the kynurenine pathway and compared them. So first up again, the control flies and the zinc deficient fly. We already concluded that no, so no extra points. So what about zinc bound to 3-hydroxykynurenine? Are they equal? Close. No. And what about zinc bound to xanthoranic acid? Yes, great. So, well, what do we do now? Well, actually, similar to like in a crime scene where several fingerprints can be corresponding to different criminals, like we thought, well, how about we mix these spectra? Are they equal now? Yes, resounding yes, in my experience. So now we have shown that up to 80% of the zinc in these organs is actually bound to kynurenine pathway itself. So the kynurenine pathway is essential for storing zinc in Drosophila. Great. Returning to the burger question, the secret ingredient in the meat burger is tryptophan, at least for Drosophilas. We have to make more experiments with other animals and, of course, humans to get a better conclusion. But still we can dream, right? So what could we learn from connecting the previously completely separate kynurenine and the zinc pathway? Well, first up, we could learn how to avoid malnutrition in the future, for example, for vegans. We could dream about improving supplements, for example, similar to folic acid or iron during pregnancy. And we could just get insight from these two pathways, which both separately so far have been connected to aging, the immune system, and neurodegenerative diseases. So, for example, severe COVID-19 patients showed high levels of kynurenine and low levels of zinc in their bloodstream. And our study would suggest that this is actually the body just screaming and signaling, I need zinc, damn it! So, we have a lot to learn still and discover about nutrition in general. And thus, in order to improve our understanding and then reduce the environmental cost of our food, as well as the damage it's doing in the world. And our son is doing great. So thank you very much for your attention.